Hello guys, how's it going? Okay, now I increase the sound.
Hate YouTube.
Okay, I can see myself. Can you also please confirm if everything is okay? Okay, nice. Okay, how was the contest today, guys? Did you participate or not? We are gonna today talk about DP Bitmask, especially about Bitmask. I'm gonna talk about everything about Bitmask. Why? You. How was it? I mean, just give your feedback. I would appreciate it. Any feedback that you give to improve it in future. I'm gonna talk about bitwise operations and Bitmask. We're gonna start from very simple things and from very basics and move on to more complicated topics. Yes, I do research. Yeah. Okay, I see. So let's move on the problems and let's talk about what Bitmask is and let's talk about how we can use it in different problems. Well, first of all, I want to talk a little bit about some bitwise operations that we have and how they are. Well, basically, change color blue. Do you want to change color, please? If you want, I change it during the stream. So basically, first of all, we should be familiar with what base 2 is. What does it mean when we say that we write some number in base 2? This is very important, especially when we want to talk about in many problems, in many topics, it's important to consider numbers in base 2. So first we need to be familiar with what base 2 is. And for example, assume that you have a number like 13. When we write 13 like this, we are writing it in base 10. Guys, I'm starting from very basics, but I'm not gonna stay a lot on this because I know that most of you want to get to where things get more challenging, but I'm gonna go over them quickly as well. For further, I will tell you about some resources that you can see them for further research and etc. But to quickly mentioning these things, 13, for example, is in base 10. I mean, this one that you see is, let me change this angle a little bit. This 13 that you see is this 1 times 10 plus this 3 times 1. So this is this 3 times 10 to the power of 0 plus this 1 times 10 to the power of 1. If I had more digits, the next one had value of 10 to the power of 2 and so on. Yes, this session will be saved afterwards, yes. And if I want to write it in base 2, it would be something like this. It would be like 8 plus 4 plus 1. So it would be, in base 2, it would be like this. Because it is 1 times 2 to the power of 0 plus 0 times 2 to the power of 1 plus 1 times 2 to the power of 2 plus 1 to the times 2 to the power of 3. 2 to the power of 3 plus 2 to the power of 2 plus 2 to the power of 0, you can see that this is equal to this 13 that we had in here. So 13 in base 2 is going to be 1, 1, 0, 1. Okay, so is it familiar? Are you guys all okay with base 2 now? I mean, we just quickly went over them. If you need further discussion about what base 2 is, we can talk more about it. But I just wanted to introduce it very quickly, what base 2 is. I will also send you a resource to read about base 2 and binary numbers in general. You can read in this Wikipedia page, and you can see that what binary numbers are and read more about them if you want it. And there are some bitwise operations that we have. For example, we have AND. For example, we have AND of two numbers, or of two numbers. We show it like here, like this. And XOR that we show like this. I'm gonna introduce what each one of them mean. In our code, we show them like this. Though in mathematics, it's usually showed like this. I mean, AND is showed with this sign, OR is showed like this, XOR is showed like this in mathematics. In mathematics notation, it is like this. In C++ notation, it's like this. I'm gonna talk about what each one of them mean. Well, guys, AND means that something, I mean, in general, when we talk in normal English or any other language, when we say something and something else, it means that both of them must be true. For example, it is raining and I'm going out. It means that both, it is raining and I'm going out. So when we have AND of two things, first, let's assume that we have only true or false, true and false. Well, when we have X and Y, if both of them are true, X is true and Y is true, the fact is that if let's show the table. This is true, this is false. If both of them are true, the result is gonna be true when we have AND, which can show it with this sign or this sign. Where one of them is false or both of them are false, the result is gonna be false. So it means that something and something. On the other hand, if we have OR, if one of the two things are true, the result is gonna be true. If both of them are false, the result is gonna be false. When we have OR. And when we have XOR, XOR is exclusive OR. It means that exactly one of them are right. For example, this is blue or orange. It means that it's exactly one of them. It's not possible that both of them are true. So it's only true if exactly one of them is true and the other one is false. This is XOR, exclusive OR. In C++, it's showed like this, with this sign, and in mathematics, it's shown like this. So, now assume that we have two numbers greater than 1, and we want to see, for example, the numbers can be have any number as well. I mean, they do not have any upper bound. So we have, for example, assume that we have 13 and, for example, 7. We want to see what does it mean. What does 13 and 7 mean? Well, it means that let's write them in base 2. We can write it both in like this or like this. It means that let's write them in base 2. 13 in base 2 is gonna be 1, 1, 0, 1. 17 in base 2 is, it's not 17, sorry, 7. In base 2, it's 0, is 1, 1, 1. In order to make it 4 digits, I add an additional leading 0 in here so that both of them have equal number of digits. It doesn't change anything if you have you add an additional 0 at the beginning. And when we calculate the AND of these two values, it means that we're gonna go bitwise, and for each bit we calculate AND. For example, in here we see that both of them are 1. So, and because we have AND, when both of them are 1, the result is gonna be 1. But when at least one of them is 0, the result is gonna be 0. And these two are both 1, so here we have 1. These two, one of them is 0, so this is gonna be 1. this 0. And you can see that this will be equal to 1 times 2 to the power of 0 plus 0 times 2 to the power of 1 plus 1 times 2 to the power of 2 plus 0 times 2 to the power of 3. So the result is going to be 5. So 13 and 7 is going to be 5. In the same way, we can use OR or XOR. For example, let's say two numbers like 21 and 15. What is 21 to in base 2? It is 16 plus 4 plus 1. So it would be like this. What is 15? 15 is like this. 8 plus 4 plus 2 plus 1. Assume that we want to calculate XOR of these two numbers. When we calculate XOR, we go on bits, and one of them exactly must be 1, so that the result will be 1. So this is going to be 0, because both of them are 1. This is going to be 1. This bit is going to be 0. This bit is going to be 1. And this bit is also going to be 1. So XOR of them is going to be this, which is 16 plus 8 plus 2, 26. Okay. So this is how XOR works. So far we have talked about binary representation, and XOR operations. XOR and OR operations. Or in other words, bitwise operations. I mean, we are gonna do this when we have XOR and OR of two numbers. We're gonna calculate the values bitwise. I mean, first we calculate the first bit, then second bit, and so on. And in binary representation, we call each digit a bit as well. Each one of them is either 0 or 1, and we're gonna call it a bit. We call each digit a bit. So, looking at the numbers like this in this way, I mean, look at them in base 2 has many benefits, and it's gonna help a lot. Looking at them like this. Yes, for example, you have set some formula that is correct. X or Y is equal to, for example, yes, X plus Y minus 2 times X and Y. You can prove it if you want. This is always true, yes. Because only in the bits that both of them are 1, you added them, but you had to remove both of them. XOR is opposite, right? What do you mean by XOR is opposite? Turn the other question. I will answer these questions later. I will answer this question later. So, this is also true, yes. What do you mean by is it opposite? XOR is opposite. Thank you very much, Adarsh. Thank you. So basically these are bitwise operations and binary representation. This is very important. No, it's not opposite to AND. NAND is opposite to AND, which is not important for now. But I mean, we're not gonna use it anywhere. In AND, both of them must be 1. In XOR, exactly 1 must be 1. Okay? XOR means exclusive OR. It means that one of them is 1, but both are not 1. Exactly one of them are 1, not both. So exactly one of them is 1. Okay, so now let's talk about the problems. I mean, let's see some problems and see what do they mean and how we can apply these things that we learned on the problems. I'm going to start with simpler problems. The first problem that we're going to discuss is this 1042B vitamins. It says that Berland shop sells n kind of juices. Each juice has its price Ci and has some set of vitamins in it. There are 3 types of vitamins, vitamin A, B, and C. Each juice can contain 1, 2, or all 3 types of vitamins in it. Petya needs all types of vitamins to stay healthy. What is the minimum total price of juices that he has to buy to obtain all 3 vitamins? Petya obtains some vitamin if he buys at least 1 juice containing it and drink it. So basically, we have several juices and we have n juices, and each one of them has some price Ci and it has some vitamins. The vitamins are A, B, and C. Each juice can contain some subset of vitamins. For example, in here, the first juice has only vitamin C. The second juice has only vitamin B. The third one has only has all 3 vitamins. The fourth one has vitamin A. Let me also send you the link of the problem as well. You have to say that what is the minimum cost to get all of vitamins. For example, in here you could only buy this vitamin, buy this juice, which costs 16. Or you could buy the 3 other juices, which would cost in total 15. 15 is better, so the answer would be 15. So in this question, each juice has some cost Ci and has some subset of vitamins, some subset of A, B, and C. One of them or 2 of them or all 3 of them, it has them, and you want to say that what is the minimum cost that you need to pay for the juices to have all the vitamins. Well, the point is that in this problem you can look at each of these vitamins that they have in binary representation. Let's consider we have a number, binary number of length 3. We have 3 digits, 3 bits. Each of them are either 0 and 1. For example, if we have 0, 1, 0, it means that this juice has only vitamin B and does not have vitamin A and vitamin C. So the point is, each of these bits indicate if it has some specific vitamin. If it had that, we said 1 there, 1 in that bit. Otherwise, we said 0 for that bit. It means that it does not have that vitamin. We look at it like this. For example, if a number is 1, 1, 1, it means that it has all the 3 vitamins, for example. So the point is that in this problem, if we take a look at this, in this problem, at the end, we want to have some of the vitamins. For example, this 0, 1, 0 in base 2 is going to be equal to number 2. Or for example, if some of them had vitamin A and C, if it had vitamin A and C, what is it equal to if I want to see that what is the numerical equivalence for this number? 1, 0, 1. This is a representation in base 2. If I wanted to look at it like a number in base 10, it's not a number, but I can look at it like a number in base 10. What was it equal to? If we have vitamin A and vitamin C, what is this number? 101. We have 101 in base 2. What is it in base 10? It's gonna be 1 times 2 to the power of 0 plus 0 times 2 to the power of 1 plus 1 times 2 to the power of 2. Exactly. It is equal to 5. Exactly. Thank you. So it's gonna be equal to 5, for example. I mean, 5 means that that one has vitamin C and vitamin A. And then we can define some dp on it. dp of I and some mask means that, I mean, dp of I and some number. This number is either 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7. Because assume that we have only considered first I people, first I juices, I mean, and the ones that we have the juices that we've bought, all of them is some number, like B. At the end, this B should become 7. 7 means that we have all 3 of them. And the point is that when you get several juices, it's like you're calculating OR between them. You have OR of all of them, because each bit, if in one of them it is 1, in the result it's going to be 1 as well, if only in one of them is 1. If in more than 1 is 1, it's even better. Okay. So we want each vitamin to be 1 in at least one of them. Even if it's more than 1, it was 1, it's okay still. It has no issues. And the point is that you can just simply, for example, if your current state is I and B, you have only considered first I people, and you have this number B so far. What is the minimum cost? The point is that from here, you can consider I plus 1. Either you get juice number I plus 1, or you do not get juice I plus 1. If you get juice I plus 1, your vitamins will get OR. You have OR of the current vitamins you have and the vitamins in the next juice. And you're gonna go to the state of I plus 1 and B, or the vitamins that juice I plus 1 has, and the cost to go here, the cost will be added by C of I, or you're gonna go to I plus 1 and your cost does not change. You do not buy this. B does not change as well in that. So B will remain the same. And the cost is gonna be 0. So you either buy the next juice, or you do not buy the next juice. If you buy the next juice, you have to pay for it. But this B can get bigger. We will have B or V of I plus 1 instead of it in the next step. But in this case, B will not change. And you're not paying anything and you're not getting any juice. This way, at the end, you can simply just see that what is dP of N and 7. Which means that what is the cost if we consider the first N, all of the N people, and your cost is 7. Is it clear what I'm talking about? If it is, please put a plus or use this emoji. Put a plus in the chat or use this emoji. If it is not clear, also let me know. So basically, I was saying that we are considering we are considering the first I juices, and we are saying that if I want from these I juices, I have these vitamins so far, I got these vitamins so far from these juices, what was the minimum cost that I had to pay for that? What was the minimum cost that I had to pay to get these vitamins from the first I juices? And then I could easily update it. I could say that either I get the next vitamin, I get the next juice and I get its vitamins, or I do not buy the next juice. So I have to consider both of the cases, and this way DPs will get updated. Is it clear or not? I will also show you my code as well, but let me know first if it is clear or not. If you have any questions so far about it, you can tell me. You can also only store the minimum cost per mask and then run a loop in bits of loop index. Only take the mask for set bits of loop index and if the OR of this. Yeah. Share our thoughts on AI and job future. We will talk about it later. Maybe at the end of the stream, if you don't mind. Sorry, because so far we have to focus on Bitmask. You are given n columns with other. So you're asking the next question, I guess. Diraj, is both clear and not clear? I will show you my code as well. So Let me also show you my code. So this is the problem, and the code will be like this. I have some DP. Initially DP of 0 and 0 is 0. I set all the other DPs to inf, to a very big number. When I have mem set DP 63, it means that set them as a very big number. 63 means that all, it's not important. I mean, let's not focus on it, but this is some sort of binary representation as well. It means that set all of the bits 1 for all those values of DP. And then in here, I get each vitamin, I get each cost and vitamin for each juice. And I see that what is gonna be the mask that I have. But the point is that usually we call these values that we're talking here, a mask. I mean, this way of showing numbers with 0 and 1s is called bit masking. So it's like a mask. For example, I know that 110 means that I have vitamin A and I have vitamin B, but I do not have vitamin C. No vitamin C. This is bit masking. I have a mask with bits. I have a mask with bits. 1 means that I have that specific thing. 0 means I do not have that. So with bits, I'm showing a mask. So it's like with numbers, I mean, all the numbers that we see are gonna be like a mask. For example, 6 in base 2 is 1, 1, 0, and it means that I have A, I have B, and I do not have C, no C. This is called bit masking, and usually we call this a mask. This is called a mask. That's why most of times it's also called, this variable is also called mask. It's better if usually you use the name mask for these bits, because it makes your code more readable and more clear. And if you wanted to know that what is the reasoning behind the name of bitmask, this is the reasoning behind that. It's like with some bits, you are doing some masking. And then if we go back to the code that we had in here, we have mask or equal to 2 to the power of s of j minus a, and then we say that dp of, I mean, for each m, we have a for on the masks that we had previously. I mean, assume that previously our mask was m. We know that the mask that this vitamin adds is this mask. I mean, I calculate this mask. I have to, each time, I have to go over this string. And if it has some a, I mean this part, 2 to the power of s of j minus a. This part just means that if s of j is a, I should add 2 to the power of 0. If s of j is b, I should add 2 to the power of 1. If s of j is c, I should add 2 to the power of 2. So I'm adding that value to my mask. I'm saying that mask or equal to that. For example, if this is c, mask or equal to 2 to the power of 2. Make this bit 2, the third bit with index 2, 1. And then I have a for m from 0 to 8, and I say that dp of I plus 1 and m or mask. This is the case that I take this juice. This is the case where I take this juice, I buy it. And the second case is the case where I ignore this juice. I do not buy it. I ignore the juice. dp of I plus 1 and m or mask will be minimum of dp of I plus 1 and m or mask, the current value that it has, and dp of I and m plus c, which means that I previously, my mask was m in the first I people, and then I'm buying this new juice. My mask will be m or mask. And dp of I plus 1 and m, this is the case that we ignore, is going to be minimum of dp of I plus 1 m and dp of I and m. At the end, I say that if dp of n and 7 was greater than 10 to the power of 6, it means that its value has not changed. I have not found, I mean, it means that I have not found any way to make all the vitamins. That's the only way that this number can remain this large, because otherwise I know that I have at most I have to buy at most 3 juices to have all the vitamins. One of them has A, one of them has B, one of them has C, and each of them costs 10 to the power of 5. So if the cost is going to be greater than 10 to the power of 6, this is not really an answer. It means that I have not found any way. So I make it -1, and at the end I will see out this DP, and this is going to be my answer. So with bitmasking, with showing the states with bits, we could just save anything, store anything, and we could easily see that so far how many bits do we have and how many bits we do not have, which vitamins we have, which vitamins we do not have. At the end, we consider the case that we have all the vitamins. Is it clear? Is there a greedy solution? It's possible to, because it's only A, B, and C. There are only 3 vitamins. Yes, there are only 3 vitamins. We can do greedy as well. We can have some cases and see each of the cases. For example, if we have A, B, C, there would be some, if there are some values that have A, B, C, there's going to be something. And then I think that greedy, because we only have 8 cases for mask, we can also have the same approach but call that greedy in another way, but with another implementation. I feel the bit explanation is pretty clear. However, I would like to see a visual explanation of the DP parts. Sure. Assign the direction there to columns with objects at this. I don't know what was that. Okay, so basically what we are saying is that right now we are at DP of, for example, I at some mask. Right now we have some bits. The point is that I can go to DP of I plus 1 and either buy this new juice. This way my cost will be added by CI. I will go to DP of I plus 1 and mask, or let's call it the current mask, or assume that this the mask of vitamins that this new juice has is B sub I. I will go to DP of I plus 1 and mask, or BI, or I do not buy this, so my cost will not change, and I will go to DP of I plus 1 and mask. So DP of I plus 1 and mask will be minimum of itself, and DP of I and mask, DP of I plus 1 and mask or BI will be equal to minimum of itself and DP of I and mask plus C sub I. This is the case that I buy the next juice, and the other case is the case that I ignore it, I do not buy it. Is it clear now? So for instance, if you want, I can drive run on a case as well, very quickly. So if you take a look at the first example in here, let me know if it is not clear in your screen. If you take a look at it, initially only DP of 0 and 0 is 0. The rest of the DPs are inf. They are very big numbers. This state has answer, DP of this state has answer 0. And then we see 5 and C. It has vitamin C, so its binary representation is 1, 0, 0. This one has vitamin B, so its binary representation is 0, 1, 0. This one has all 3, A and B and C, so its binary representation is 1, 1, 1. This one only has A, so its binary representation is 0, 0, and 1. So it's like this number is 4, this number is 2, this number is 2, this number is 7, and this last number is 1. So first, when you see this number, I mean, it's possible that you buy this, and go to DP of 1 and 4. DP of 1 and 4 gets equal to 5 here. And then you see the next one, B. Well, you can, with B, you will again update the next DPs. For example, DP of 0 and 0 can go to, and also we can say that DP of 1 and 0 is also 0. Because this is the case that you will ignore. The next, you will ignore this juice. And then when you see B, you can, from this one, you can both ignore this next juice or get this juice, buy this juice. So you can either go to DP of 1 and 6, which is 4 plus 2. I mean, it means that we have those two bits, bits 4 and bits 2. Bits with value 4 and bits with value 2. And this gets equal to 5 plus 6, which is 11. Or we will ignore this one and we get to DP of, again, our DP is gonna have mask 4 and its cost is still 5. And from this one, we either get this B again, which will go to DP of 2 and its value will be 5, or we ignore this one as well here, which we get is still our mask is 0 and our value, our cost is also 0, and so forth. Sorry. So this way we can calculate that how our DPs are. Awesome. What is memset? Memset is only for setting the numbers initially. It's like I could, instead of this line, have a 4 and make all of the DPs equal to inf. This is just saying, by memset, I have some array and I set all of its values by this code to inf by setting it 63. When I'm using this, I'm making all the numbers infinity. I mean, the greatest number that I can do. But you do not need to worry about that a lot. Memset is usually used when you want to set all the values 0 or all the values -1. That's the most of the case that you want to use it. But usually it's used only for 0. When you set memset, when you say memset DP 0, size of DP, you set everything to be 0. When you use 63, for example, like in this code, I'm making them a big number. A very big number. This one. Awesome. Is your code there, or are you adding the costing? Yes. Okay, awesome. So this was how this DP could be used in this problem. Let's talk about another problem that also uses this binary representation. Let's talk about that as well. It says that this is 579A, rising bacteria. It says that you are a lover of bacteria, you want to raise some bacteria in a box. We should go a bit faster, so I'm going to read it faster and talk about it faster. Initially, the box is empty. Each morning, you can put any number of bacteria into the box, and each night, every bacterium in the box will split into 2 bacteria. You hope to see exactly X bacteria in the box at some moment. What is the minimum number of bacteria you need to put into the box across those days? So you want to have several bacteria. Each day you know that each bacteria will split into 2 bacteria. Each bacterium, I mean the single form of bacteria is bacterium. Each one bacterium will split into 2 bacteria each day. So if today you have X bacteria, the next day you have 2X bacteria. Okay, this is the formula. And each day you can add some bacteria to the box as well. You have to say that what is the minimum number of bacteria that you need to put into the box across those days. Again, in this problem, you know that each day you can, for example, add 1 other bacteria into the box or more, and then the next day it would be twice. I mean, It would be multiplied by 2. The point is that if you take a look at it in binary representation, it's like if you show the number of factorials you have in base 2, it's like each day you're adding a 0 at the end of it. So like how in base 10, we usually write numbers in base 10. I mean the traditional way of writing numbers is to write them in base 10. When you write them in base 10, when you multiply a number by 10, it's like adding a 0 to the end of it, because each digit is shifted, so its value will be multiplied by 10. In base 2, when you multiply a number by 2, a 0 will be added to the end of them, because each bit will be shifted to the left and its value will be multiplied by 2. So it's like you're adding a 0 to the end of it, and by adding one factorial, you're just adding 1 to it. For example, if the last bit was 0, you can make it 1. So the point is that if you have some number, let's consider the first case, when we have 5. The first case when x is 5. We want to have 5 factorial. We know that 5 in base 2 is 1, 0, 1 in base 2. Well, the point is that for each of these ones that we have, we definitely need to put some bacterium into the box, because we know that by adding each bacterial you can make at least one digit of 1. So the point is that first you can add one bacteria, the next day you're gonna have 2 bacteria, the next day 2 bacteria, the next day you have 4 bacteria, the next day you have 8 bacteria, the next day you have 16 bacteria. So the point is that if you look at it in base 2, it's like initially you have 1 bacteria, I mean in base 2 is also 1, the next day is adding 1 0 to the end of it, the next day again 1 other 0, the next day again 1 other 0, and so on. These are in base 2. So when you want to make 5, it means that in here you want to make this bit 1 as well, so you have to add another bacteria in here as well, so that it becomes 1 0 1. So the point is that when you are making the number you have, each time you're multiplying it by 2, and then if you want that bit to be 1 in x, you can add 1 additional bacteria there and make that 0 into a 1. So basically what this problem is, it's basically is asking you can just simply for each x just see that in binary representation how many 1s do you have, and that is gonna be your answer, because each day you're gonna add a 0 at the end of your binary representation, and you can see that if you want that bit to be 1 or that bit to be 0. For example, if your binary representation is 0 1 0 0 1 0 1 and so on. So initially you have 1 bacteria. Initially you have to add 1 bacteria. The next bit, the first bit is 1. Then you multiply it by 2, and then you add 0. The next bit is 0. Then you multiply it by 2, and then you add 0, because the next bit is 0. Then you multiply by 2 and add 0 again. The next bit is 0. Then multiply by 2, and this time you have to add 1, because this bit is 1. Then multiply by 2 and add 0, because the next bit was 0, and then multiply by 2 and add 1, because the next bit is 1. So you will go like this, and you will see all these. You will calculate all these numbers, digits. And this way, it basically saying what this problem is asking you is to calculate that how many 1s do you have in binary representation of the given number x. And in order to find that out, there's a function in C++ named built-in pop counts. This problem is simply asking you to see, when you see in x, you see out built-in pop counts of x. You see out that how many set bits x has. So this problem was actually more about binary representation and how it would be like. I mean, we just solved it using binary representation of x. Is it clear? Did you guys understand it well? If it is clear for you, please put a plus or use the 100 emoji. If you add a bacteria thing, Exactly. Exactly. So you can say that each bacteria, the effect that each bacterium contributes, the effect that it would contribute is 2 to the power of something, 2 to the power of the number of days that has passed from the day this bacterium has came. Is 2 to the power of that. So you can say that each bacterium contributes 2 to the power of something. So it's like the question asks that if we have sum of several 2 to the power of some things, what is the minimum number of these numbers that we can sum up to make x? And it's always the best to use those bits that are 1 on the binary representation of your number. Is there an equivalent function in Python? It must be. Let me see a Python code as well. Let's see how they've done it in Python. Yes, it's that count of 1. I mean, this person has, as input has got some string instead of some number and has calculated that count of 1. I guess maybe even for numbers there must be a way to calculate how many set bits do they have. But they have used a string. So one case that you have is a string. It's to get the input as a string and then say dot count of 1. Okay, dot bit counts. Dot bit counts. Int of inputs dot bit counts. Bits underscore counts. Okay, forget the previous thing that I said. That was not important. So just say int inputs dot bits underscore counts. Is it clear? Vru, why you late this much? Who are you talking with? Is it with me or are you talking with me or someone else? And about the rest of it, do you have any other questions or shall we move on to the next problem? So, awesome. So, let's move on to the next problem as well. Let me for a second. And unfortunately, it seems like my laptop has some internal damage, as I had previously told you in the previous streams. My webcam has become blurry, and you see my picture a little bit blurry. Is it blurry right now? Do you see my picture blurry? My video, when right now it's on laptop webcam. It's a little bit blurry now, and whatever I do, it has no effect, unfortunately. A bit blurry, I see. Sean, can I contribute for your research? You can especially contribute to the channel if you want. Okay, it's okay. Nice. So, let's talk about the next problem. The next problem that we had is this one, 1151b. Dima and the Bad XOR. Okay. So, it's saying that a student Dima from Kremland has a matrix A of size n by n filled with non-negative integers. He wants to select exactly one integer from each row of the matrix so that the bitwise exclusive OR of the selected integers is strictly greater than 0. Help him. Formally, he wants to choose an integer sequence C1, C2 to Cn so that the inequality A of 1 and C1 XOR A of C and 2 and C2 and A of n and Cn is greater than 0 holds, where A of I and j is the matrix element from the ith row and jth column. So, from each row, we want to choose. We have a table. We have some table. And from each row, We want to select one of the numbers such that the bitwise XOR of those numbers that we choose would be non-zero. And I think the problem author is also Polish because it's Tak and Nai, if I'm pronouncing them correctly. There was a very good website, Polish website, that had a lot of good problems, I remember. I think so. I guess that this author is also Polish, but anyway. So we have this table of size n by m. From each row, we can select one of the numbers so that at the end, when we calculate the XOR of all these numbers, that would be non-zero. So I say that let's do a simple approach. Let's take the first number from each row. Let's just choose the first number from each row and see what is their XOR. So take the first number from each row and see what is their XOR. If it is non-zero, then great. We already have a non-zero answer and the problem is solved. If it was non-zero, it is already solved. The problem is already solved and we have found the way. But assume that it is zero. If it is zero, if it is equal to zero, if in any row, for example, assume that in some row, we have at least two distinct numbers. So assume that this number is x, but all the numbers are not same in some row. For example, this is x, but we also have some y instead. We can just, in that row, instead of x, choose y. Then definitely something would change. Some bits that was 1 in x will become 0, or some bits that was 0 in x will become 1. And the XOR in that bit will change as well. We know that if x and y are different, they are different in at least one bit. And the result of the XOR of that bit will change. If we change that bit in this number, in the results that bit will change as well. So if in some row we have some different number, we have the chance to change the number we have, we're gonna find an answer that is XOR is non-zero. But if in all of the rows, all the numbers were equal, there's nothing that we can do. And definitely the XOR will remain the same because all of them are in each row are the same. So there's definitely no way that we can make it non-zero. Is it clear? It was some sort of greedy sort of. But the point is that we had to look at it with binary representation. We had to look at this problem with binary representation. No, Mr. Nur, thank you. In what? In football or in CP? Thanks. Do you guys watch soccer? Are you guys a fan of soccer? Skills. Thank you. I was a great fan of soccer previously, but when I came here to the US, all the matches are in the afternoon. They're not in night anymore, and I miss most of them. It's really hard. What team do you support? I was always a fan of AC Milan. From my childhood. What team do you guys support? Bitwise. So, in the meantime that you're answering that, if that is clear, I will also show you some code about this solution. So basically, I was just saying that in each row, I will just consider the first number initially. If the XOR was initially non-zero, that's very good. It's non-zero. Otherwise, if at some row I could change the number, it would make the XOR different and the whole XOR will be non-zero. But if all of them are the same, there's nothing that we can do. And basically the XOR will remain 0. So let me also show you some codes. I have not implemented it myself, so I will find another code to show you guys. So, okay, as you can look at the solution here, it's just saying that this code says that initially you are calculating the XOR of the first numbers in each row. You calculate the XOR of each the first number in each row, and then you say that if it was not 0, that's good. If it's not 0, we have everything. But if it was 0, we do this additional thing as well. If it was 0, we will have a 4 on all the numbers, all the rows. And then we say that if one of the numbers was different compared to the first number in that row, we will just change ans of I, and instead of taking the first number, we will take number in row J, and then we say that flag is equal to true. It means that we have found the answer and we will break. If flag was not true at the end, we will just see out no, there's no way, because in that row all the numbers are equal in all of the rows. And at the end, I will say that if this did not happen, if either flag was true or initially from the beginning issue was non-zero, the answer is yes, and we will print all the answers. And the point is that in the answer that you will print, always all the answers, all the rows that you will print, except at most one of them is 1. If you look at it, in each of the answers, all the numbers you print except 1 is 1. I mean, at most one of them is not 1. For example, this example shows it well. Everything is 1, maybe at least in one row you take another number. Okay, so this is how your output would look like at the end. Is it clear? Yes, that's the shortcut. Did E in last contest in just 5 minutes on the tricks on? Oh, that's sad. So you guys were not a fan of football, because I see that I just saw a fan of Real Madrid and a fan of Messi, but no one else was a fan of football. What was the trick? The trick was that if we change one number in our XOR, the XOR will be non-zero. I support whoever wins. Cricket, you're a fan of cricket. I see. Are you from India? I know that in India, Pakistan, especially, I know that you're crazy about cricket. I've heard about it. Who are the best teams in cricket? I've never watched cricket, and I've never learned the rules of cricket. I never tried actually as well, but I think it's interesting. I mean, the fact that some people are crazy about it means that if you see what it is, you see that it's interesting. In Bangladesh, people are also crazy about cricket. In that area, everyone are crazy about cricket. Interesting. India, Australia, England, Sri Lanka. Interesting. Cricket is interesting to watch, boring to play, in my opinion. You know Kabaddi? I don't know that, no. I don't know Kabaddi. Oh, Kabaddi. Kabaddi, yes, I know Kabaddi. You have to hold your breath. I know. I was misreading it. It's Kabaddi, yeah. I know. And I think Iran was also good in Kabaddi. I know that India was the best, but Iran was also good. Is that true? I haven't watched Kabaddi a lot, but as far as I know, it's like this. Glad to see you have some other things that interest you other than CP. Yeah, definitely. Definitely. Yes. Okay, so are you guys ready to talk about the next problem as well? Have you understood everything so far? Is everything clear that that I talked about? Guys, if anything is not completely clear, let me know. I will discuss it again. I want to make sure that you understand everything that I say. So Feel free to say if anything is not clear. I don't want to talk about the things and see that some people have not followed it and have not learned from it. I want to make sure that you've learned everything. So please let me know if it's clear. I'm sorry that I'm drinking while I'm streaming. And it's very early morning in here. I mean, the reason that I started late was that it was very early morning and it was 8 o'clock. I started at 8:10. Sorry for that. Thank you. One of the best matches was India vs Iran, a small fact. Oh, interesting. Maybe you can send a video of it. Alright, so let's move on to the next problem now. That was interesting. It's great to learn new things. I'm learning some things about you, about the things you know as well in the streams. Twitch, man, do you want to move on to Twitch? You want to leave YouTube and move on to Twitch? To be honest, I'm not really very satisfied with YouTube as well. So, if you guys prefer to move on to Twitch, have the streams on Twitch, we can test that out as well. I think there's no issue in testing that out as well to see how that would be. Okay. So let's move on to the next problem. Let's talk about the next problem. Twitch minus I can't afford. Why? Why you need to afford? It's not free? Okay. Let's talk about the next problem that was in a recent contest and I solved it it was a D4 contest. So it's problem G, 1950G. Problem G of a D4 contest recently. I guess it's free. It's free. So it's saying that Vladislav has a playlist consisting of n songs numbered from 1 to n. Song I has genre GI and writer WI. He wants to make a playlist in such a way that every pair of adjacent songs either have the same writer or are from the same genre. So you have several songs, each song has a writer and some genre, and you want to have a playlist, each two adjacent songs, either their artist must be the same or their genre must be the same. Otherwise he gets confused if everything changes. He calls such a playlist exciting. Both GI and WI are strings of length no more than 10 to the 4th. It might not always be possible to do that, so he can remove some of the songs. He can remove some of the songs and then the remaining songs in the playlist will be rearranged to make it exciting. And he wants to find the minimum number of removals so that at the end he can have his playlist. He can arrange his playlist so that each two consecutive ones have the same genre or have the same writer. And you can see that n is at most 16. Guys, always keep this in mind. In Bitmask problems, the constraint on n is very low. Because usually you have to use 2 to the power of n. So when you see that in a problem n is up to 16 or something like that, it means that when the constants are this low, it's kind of giving you some hints that you have to apply bit masking on this one. Because if you have a mask of length 16, it's gonna have at most 2 to the power of 16 ways. You have 16 bits, each of them can be 0 or 1. So how many ways do you have 2 to the power of 16? So it's exponential and your number must be too small such that 2 to the power of that is not going to be so big. And always keep in mind that 2 to the power of 20 is around 10 to the power of 6. 2 to the power of 17 is around 10 to the power of 5. In general, you should always keep in mind that, oh my god, come on. Again, tablets. Maybe there's some issue with my wire that this happens. It's very problematic that it happens. Okay, thankfully it's got fixed. So basically you have to always keep in mind that 2 to the power of 10 is all around 1,000. It's exactly 1024, which is around 1,000. So 2 to the power of 20 is 2 to the power is 1,000 to the power of 2, around 10 to the power of 6. To the power of 17 is around 10 to the 5th. So you have to keep these approximations in mind so that you know that when you see a problem, what time complexity you can use. This way you can find out if 2 to the power of n works or not. Anyway, so these are the genres, these are the alters. You want to see that what is the minimum number of songs that you have to remove to make a good playlist. So, what do you guys think first? I mean, what are your ideas? If you want to apply bit masking, if you want to apply some mask, how do you think we can apply it so that the answer so that we can get the answer? There is channel subscription, but that's optional. I see. In Twitch, I see. So why someone should subscribe in there? This way, just to support. But anyway, focus on this question. So we have some. We want to apply some bit masking. How do you suggest we can do that? What can mask mean? States 2 to the power of I is 1 initially, then check for which state can be reached from which one. What is the definition of your states? Generate all 2 to the power of n result and compare adjacent pairs for the area of each result. Interesting. Davis manipulation seems like surgery. We will use DP to calculate the minimum number of removed songs. These are all very interesting ideas. Good job, guys. The set ij is some subset of 0 to I can be used. Yes, songs will be rearranged at the end. At the end, songs will be rearranged. Yes. So basically, otherwise it could be solved in O of n squared, I think. If they wouldn't rearrange, you could just keep that. What was the last one that you haven't read? So what we can say in this problem is we can have some dp of this time mask and I, which means that I have used all the songs in mask. The songs in mask are used, I mean they are in my playlist so far. Maybe I add the other songs as well, but so far I've added the songs in mask to my playlist. I have them, and the last one of them was song number I. I is definitely in mask. So mask is a binary representation of length at most 16. Its length is n. N is at most 16. So we have a binary representation of length n. Each bit is either 1 or 0. 1, 0, 0, 0, 1, 1, 0. For example, like this. It means that I have this song so far, I have this song, I have this song, and I have this song. Each one of them say that I have that song so far or not. And I means that this is the last song in my playlist. Only the last song is important, because when I want to add another song to my playlist, to the end of my playlist, I have to compare it with the previous song. I have to see that if they are from the same genre or from the same artist compared to this song number I, then I can add them. Otherwise, I cannot add them. So basically, what we can say is this. Initially, for each pair of songs, like I and J, I will see that if they can come after each other or not. For each I and J, I will find out if they can come after each other or not. If they could, I put a 1 here, otherwise I put a 0. So it is just I check that if their genre is equal or their genre is equal or their author is equal. And then I say that when I have mask and I will have a 4. on the next song that I can add to my playlist, I will have a for on the next song, like song number J, that I can add to my playlist, such that in this matrix, I and J must be equal to 1. The matrix instead I and J is equal to 1. I mean, this matrix is nothing special. It just means that G of I and I is equal to G of J, or writer of I is equal to writer of J. Matrix of I and J is equal to this, either this or this. So basically, I just keep that. And this is or when we want to calculate. I mean, bitwise OR was using one line, but when we are calculating OR of two statements, which each one of them are true or false, we use double OR. And if we want to have AND of two statements, which each of them are true and false, we use AND. Two ANDs instead of one AND. So this is my matrix of I and J. It says that I and J can be next to each other or not, which is equal to this. And then I have a for on all the possible J's that can be added here. If J was okay with I will add it to the end of this playlist that I have. If J was okay with I, then I can go to dp of mask plus 2 to the power of J. I'm assuming that J was not in my mask, and J. And I'm adding one more song here, so that dp will be added. So I mean, it's like my new playlist is gonna have one more song. My playlist is gonna have one more song this way. So basically, mask is equal to the number of dp of mask and I is always equal to the number of people that you have in mask. Okay, the number of songs that you have in mask. So basically that is gonna be how it works. Let me also show you how this algorithm would work in code. I mean, I'm gonna explain it once again on code to make sure that you have understood it. Let's go over step by step. First of all, I say that for each I and J, I say that matrix of I and J, this just says that if I and J are okay with each other or not. It is equal to Gi equal to Gj or Wi equal to Wj. So this is our matrix. And then initially I say that dp of mask and I for each mask is equal to 0 for each mask and each I. It's equal to 0. And then I say that as a base case, only dp of 2 to the power of I and I is equal to 1. It means that let's assume that I only have song number I in my playlist. Song number I is the first song in my playlist. As the base case, I set them equal to 1, and I set that answer is equal to 0. And I said I have a for on mask from 1 to 2 to the power of n, and for I from 0 to n. Definitely 2 to the power of I and mask must be non-zero. What does it checking? It says that, what does this if check? It says that let's assume that I have some mask. It's like this. It says that let's calculate what is the AND of this mask and 2 to the power of I. What is the binary representation of 2 to the power of I? Its bits number I is 1. The rest of the bits are 0. So it's basically, if the result is 0, it means that this bit was 0 in mask. If the result was non-zero, if it was equal to 2 to the power of I, it means that this bit was 1. So only the answer, the AND of these two values is non-zero if and only if this bit in mask is non-zero. So basically what this line is checking is that, do we have our bit number I equal to 1 in mask or not? So if bit number I is not 1 in mask, then we should not consider this case, because I is not even in our mask. I mean, this is not in the subset that we have chosen. So we should not consider it. But if it is, we can consider this case. We can consider dp of mask and I. Okay, let me know if you had any questions about this. And then I say that let's add another let's add another song. This time, if mask and 2 to the power of j was non-zero, I will continue, because j this time should not be in the mask, because I'm adding it. It must be a song that is not in the mask and I'm adding it. And I say that my new mask is going to be mask or 2 to the power of j, because 2 to the power of j will be added to mask, and mask is my new mask. If j could come after I say that dp of n mask and j is equal to maximum of dp of n mask and j and dp of mask and I plus 1. In brackets, let me also tell you that this dp could also be defined as boolean, because always, as I said, dp of mask and everything, dp of mask and every I is equal to the number of set bits in mask, or in other words, as you have learned recently, is equal to built-in pop count of mask. Always. So you could also have it as a boolean, but it's not important. dp of n mask and j is equal to maximum of dp of n mask and j and dp of mask and I plus 1. And then I say that dp of n mask and I is equal to maximum of dp of n mask and I and dp of mask and I. So okay, sorry. In here we are also considering the case that j is ignored. So basically, I mean, as I said, we could also, instead of this, we could also have only a boolean dp and just keep that if some state is possible to reach or not. If dp of mask and I is true, it means that I could make it. I could make this subset and the last one was I. Then my answer would be maximum of built-in pop count of all the masks such that dp of mask and I is true for some I. But I could also do it like this, define it as an integer and say that, okay, what is the greatest subset of mask that I can have as songs? And my ans at the end would be maximum of dp of mask and I and ans. So my answer would be maximum of all of dp's of mask and i's. And definitely at the end I should print n minus the maximum ans that I can have. Ans is the maximum that I can keep, so I should remove the rest of them. So basically dp of mask and I is the state that I have used the song in mask, and the last song that I have used is song number I. Okay, I have used these songs, I have them in my playlist. I only keep that what was the last song among them, because that is the important one. When I want to add another song, I do not care about the songs that I have used previously. I only compare it with the last song to see that if this song can be added or not. Therefore, I only keep the last song, and then I say that if for some j I can add it to the end of my current playlist, I will consider the case that I add it. I will have some transition on my dp. I say that right now on mask and I, next time I'm gonna go to mask or 2 to the power of some j, or I could say mask plus 2 to the power of some j and j. And this way all the dp's can be calculated. Is it clear? If it's clear, please put a plus or use the emojis again. How old are you? I always ask, how old do you think I am? Yes, but now everyone knows that. Why the masking? I didn't understand. I'm 25, yeah, that's right. So why the masking? Well, the point is that I had to keep for each subset of mask. I had to, because I mean I can have the songs in any order. So I'm keeping that which subset of songs I already have in my playlist. For example, right now I have song number 2 and song number 5 and song number 7. Okay, so if I have song number 2 and song number 5 and song number 7, it means that the binary representation, and assume that we have, for example, 8 songs in total. 8 songs in total. Our binary representation will look like this. 0, 1, I mean, we have to make it 0 based first. So 2, 5, 7, it is 1 based. So to make it 0 based, it would be 1, 4, and 6. It would be 0, 1, 0, 0, 1, 0, 1, 0. This mask shows that so far we have used songs. I write in base 0. I like 0 based songs 1, 4, and 6. So each mask represents a subset. Each mask represents a subset. That says that what is the songs that I have in my playlist so far. So I keep that. If my current state, what do I need to keep from my current state? If you have seen DP streams, I have talked about it, that in DP we usually keep that what is our current state. These are the things that are important for us. These are the things that we care about. For example, in here we care about what mask is, what subset of songs we have used, and we only care about what is the last one among them. The rest are not important. We only care about the last one. We do not care about the rest. Because the rest are not important. When you add another song, it's only enough if it is okay with the last recently added song. But the previous songs are not important. We do not care about them. Bro looks like Samai Ryan. I don't know who is in. I guess that he's someone famous in India. Yes, some people have said it previously. Interesting. Great. Awesome. So this is also how we could solve this problem. And guys, in this Codeforces group, you have the chance to accept the problems. I wanted to go to gym, but you have the chance to accept the problems again after the contest, so you can solve them. So if you come to the CF group, okay, it was on here. So if you come to the CF group, you can in here accept the problems after the contest as well. So if you understood the solution, I definitely urge you to try to accept the problems afterward. And if you're not in the CF group, you can join it from okay, no, let me move on to groups. You can join it from here. You can join the CF group from here, from this link. Please improve audio quality. Sure. I had 2 microphones. First, I had a microphone that was a table microphone, if any of you remember it from the first streams that I had. That was good. And then I bought a better microphone, so I removed my first older microphone. But the new microphone sucked. It was really bad. And then I removed it. And that's why I'm not using a microphone right now. But I think that I have to get another microphone again. Your way of explanation is really amazing. That's very nice that you say that. I'm so happy to hear. Yes. I summarized this the solution of the last problem once again. In short, I was saying that we have some DP of mask and I, which says that I have used all the songs I have in my playlist. So far, I'm constructing my playlist. So far, I had these songs in my playlist, this prefix. So far, I have these songs in my playlist. And the last one of them is song number I. Now I'm adding another song to the end of my playlist, like song number J. Song number J must be okay with song number I. If it is, I can have a transition from dp of mask and I to dp of mask plus 2 to the power of J, which means that I'm adding J to my playlist as well, and J. So it's like I'm trying to fix that. What is the next song that I say? I say that from my current state, the only thing that matters is that which songs I have in my playlist and what was the last song. Only I care about these two things. What was the last song and what are the set of the songs that I have used. Because I need to know that which songs are used, I cannot use them again. And also I need to know what was the last song, because when I add another song, I have to compare it with the last song. But the rest of the songs do not matter. They can be in any order. I do not care about them anymore in the future. So I don't keep them in my state. Okay, awesome. So if you are okay with that, please try to accept that. I definitely urge you to accept this problem. Understanding its solution alone is not enough, guys. I mean, in CP, you have to accept the problems. That's the most important thing. I mean, if a problem is not accepted, it's like nothing. Okay, let's now move on to the next problem. I think we have to talk about the problems quicker a little bit. We are running out of time. Or maybe I can skip the solution of the last problem and talk about it in later. So I see, we'll see that's how it would be. So the next problem that I want to talk about is another Thief tournament. It says that the rules of Thief tournaments are well known to everyone, and Thief take part in the tournament. The tournament starts with the random choice of two Thieves who will fight in the first battle. So basically it's saying that we have a tournament and N people, and they will fight with each other and they kill each other and so on. Initially, two of them will fight each other and they will kill. One of them kills the other one. So it's like we have a tournament with N people. Initially, two people fight with each other and one of them kills the other one. And then it's like we have a queue in here. All the other fighters are in a queue. The next person in the queue comes and fights with the person who remains alive. The next person comes and they fight. And again, one of them dies. And again, the next person from the queue comes and they will fight. One of them dies. So we have a queue, and each time two of the fighters are fighting, one of them kills the other one, so that one dies, and the next person from the queue comes and fights with this winner. Again, one of them dies, for example, this one does, and the next person from the queue comes and fights with this person. And it would be like this. You want to find the best order of the queue. You want to choose the first two people who fight, and then the order of the people in the queue that they will be added and fight in the next turns, so that at the end, the probability that person number one will remain alive would be maximum. We want to maximize the probability that person number one will remain alive. So, is the statement clear? I hope that there are no issues with this statement. So, what can we say about it? Well, again, what we can say is that what is the states that we can have in each turn? How can we define some states on this problem? Let's do some brainstorming. What do you guys think? How can we define some states in this problem? Could you explain why my code doesn't work? I mean, you can talk about that in Telegram channel, maybe. So, what do you think the current states could be? I mean, what are the important? At each moment of time, what is the information that we need? There are several things that we do not care about, and there are some subset of information that we care about. So we only at each time care about how many people have fought, who are the people who have fought, and who remained alive from them. If you take a look at it, you see that again in this problem n is at most 18, which again gives you some hints that you can use bitmask. Like what I said on the previous problem, usually when we the limit on n is too small, it gives you some hints that you need to use bitmasking. So it's saying that we have some subset of fighters. It's only important at any number of times which subset of fighters have fought so far and who remained alive from them. The current state can be only showed like this, and then we can decide that who we want to be next, who we want to be the next person who comes and fights. That's the only thing that we would care about. Okay, so we can have some mask. We can show our states with some mask. Mask is the set of fighters who have fought and I, that is the last fighter, the fighter who remained alive. Assume that we are in this state. Assume that right now we are in this state. I want to see that if right now I'm in this state, what is the probability that at the end person number 1 will remain alive? I said that I want to maximize the probability that person number 1 will remain alive. Assume that right now I'm in this state. Do you agree that this is all the information I need? If I want to see, if I come to this event, come in the middle of this event, the only information that I need so far is to know that which people have fought and who has remained alive. So I know that the fighter that has remained alive, and I know that which people have been killed so far, and then I know everything that is important about this state. Nothing else has any effect on the probabilities. Do you guys agree with this? Do you guys agree that this is the only information that you care about? You can again use emojis or put a plus in the chat. So I say that the only thing that we care about, is that who are the people who have fought and who has remained alive from them. So we need a mask. The only thing, if my friend is in this event and I come there in the middle of the event, and I want to ask him that what is the situation right now, what has happened, he can just tell me who has died, who are the fighters who have died, and who was the fighter that remained alive. This is the only information I need. I do not need to know that in which order they have died or anything like that. Those things have no effect on what is the probability from now. So I can keep that dp of mask and I tells me that what is the probability that person number 1 will win at the end. Person number 1 will win at the end if my state is right now the pair of mask and I. So, these people have fought and I has remained alive. I can say that, what is my base case? Let's see if anyone can find out that what is our base case here. So, what is the base case? What is the value that I can set initially? With this definition that I have dp of mask and I means that these people have fought and this person is alive. What is the probability that at the end person number 1 will remain alive if we start from this state? As I said previously, DP had 4 important phases, as I said in DP streams. One of them is define what the DP is, find the base case, and find how we can update the DP, the transitions, and see that which DP is our answer. DP of 2 to the power of I is equal to 1. Not that. That is not the base case. But that was a very good thing to mention, but that's not the base case. Because, I mean, as I said, the definition of DP is that these people have fought and this person has remained alive. What is the probability that person number 1 will remain alive? This way you are saying that if only person 1 is in here, with probability 1, person number 1 wins. If only I is here, with probability 1, person 1 will win. That is not true. So you have to find the states that if you are in that state with probability 1, person number 1 will win. What is that state? Can anyone guess that? Can anyone find that out? What is the probability of winning against I times 1 dp of mask of I and j and I is equal to p of I and j? That is not again the base case, because we want to see that if we start from this state, what is the probability that person number 1 will win at the end? So my base case is dp of everyone, all of the people is its mask is 2 to the power of n minus 1. 2 to the power of n minus 1 is binary representation is 1 1 1 1 1 1 in base 2. So we have dp of 2 to the power of n minus 1 and 1. What does this mean? It means that everybody has fought and person number 1 has remained alive. Now, what is the probability that person number 1 is alive, will be alive at the end? It's 1, because right now everyone have fought and person number 1 is alive. So this is our base case. The probability that person number 1 will end up being alive will be 1 in this case. And dp of 2 to the power of n minus 1 and anything else, any other number, any x not equal to 1 will be 0. Because it means that everybody have fought and person number x has remained alive. Okay, so these are our base cases. Now when I want to calculate dp of some mask and I, if our person is starting first in tournament and he needs to win the tournament, he'll have to win duels against everyone. What am I thinking? Yes, if he is the first person who comes to the tournament, he has to fight against everyone. But you can rearrange the queue. I mean, you are trying to find out that in which order people come. So yes, definitely it's not a wise choice to put person number 1 as the first person. You want to arrange the queue in a way that it would maximize the probability that person number 1 will win, right? So you want to arrange the queue in a way that it would maximize the probability that person number 1 will win. So it's not good. It's not a good choice to put person number 1 in the first choice, in the first position, right? So basically, we have dp of mask and I. It means that these people have fought. Person number I has remained alive so far. These people have fought. Person number I has remained alive so far. So what does it mean, and how I can do transition? Where can I go in the next step? The point again in here is that when I start from dp of mask and I can add another person, some person number j, as soon as some j is not in mask. By this notation I mean that bit number j is not 1 in mask. No, it's not compulsory to be in the first place. No, we can rearrange the positions. I hope that no one else had this confusion as well. I mean, I hope that I hope that I explained it in a clear way. Does anyone else also have doubts about this statement? Is there anyone who thinks that this statement is not clear? Let me know if this statement is not clear for you. I will explain it again. So let's consider some j that is not in mask, and from dp of mask and I, we will go to mask plus 2 to the power of j. I want to calculate dp of mask. So I want to see what is dp of mask and I equal to. I want to see if I start from dp of mask, what is the probability that I will end up with person number 1 will remaining alive. So when I add some j, I will go to dp of mask plus 2 to the power of j, and either I kills j, in which case I is again alive, and I have to see that what is the probability that person number 1 will be alive if it starts from this state, times p of I and j, because this is only the case that person number j will be the next person in the queue and I kills j. Also, j can be the next person in the queue and j kills I instead of I killing j, j kills I. So it's gonna be mask plus 2 to the power of j. Now j remains alive. I will see that I already know that what is this dp. I calculate this dp backwards. I started from dp of all bits being set and I'm going backward. This is an example, this is a solution that shows that we can also go backward on masks. So I'm going backward. When I'm calculating dp of mask and all the greater masks are already calculated. So I know that what dp of mask plus 2 to the power of j is. So when I know that I have dp of mask plus 2 to the power of j and I, which means that if I remains alive, what is that probability? Times p of I and j and dp of mask plus 2 to the power of j and j times p of j and I. And I have to add these two probabilities. If j is after I, this is gonna be the probability that at the end person number 1 will remain alive. And over all j's, I have to find the maximum of this value because I have to find the best possible j. I have to find the best possible j in here. So I see that for each j, if I set that j, if I put that j in here, I see that what is going to be the answer, what is going to be the sum of these two values, and then I will put the j, the value of j that gives me the maximum value. This sum will be maximum. So my dp will be maximum over all j's, dp of mask plus 2 to the power of j and I times p of I and j, because this is the case that these people have fought, not the next person that comes and fights with others is person number j. This is the next person who comes and fights with other people. And the previous one was I. I say that, okay, if j is after I, the previous person was not I, sorry. The person who remained alive here was I. So, this is the last person who remained alive, not the last person who came from the queue. This is the person who has remained alive. So, I has remained alive from here and j comes. If I put j, the next person in the queue, either I kills j, so we will have p of I and j for that. The probability of it is p of I and j, and the probability that person 1 will win at the end from that state is going to be this, dp of mask plus 2 to the power of j and I, or j kills I, and the probability of person number I winning from them is going to be mask plus 2 to the power of j and j. So we add up these two probabilities and we say that what is going to be the sum of them, and for all the possible j's we will calculate the maximum of this value. Is it clear? If it's clear, please put a plus or use the emoji, otherwise this emoji. Otherwise, if it's not, ask me questions or put a minus. Chan, what is the channel that you mentioned in which we could contribute to your research? No. I said that maybe you can contribute to this YouTube channel if you want it. If anyone wants it. I do not have a channel that is related to research. So, did you guys understand the solution? Why are you adding both these? Because both of them are possible. You know, I'm saying that I start from mask and person number I has remained alive. So I'm saying that the next time when J comes, it's possible that I kills J and it's possible that J kills I. Both of them are possible, and in both of the cases it's possible that at the end person number 1 will remain alive. So I have to say that if I kill J, what is the probability that 1 will remain alive if that occurs? And if J kills I, in that case, what is the probability that person number 1 will remain alive? So we have some good outcome that we want. There's some good outcome that we're looking for. That person number 1 will remain alive. There are 2 possible outcomes in this action that we have if J comes after I. Either I kill J, I should find out that what is going to be the answer at the end, the probability of the good outcome, if I kill J here. And also it's possible that J kills I. I should see that, I should find out what is the outcome, what is the probability of that outcome, what is the probability that person number 1 will win at the end if that happens. So I have to calculate each of these 2 outcomes and add them, because in both of the cases I have some probability of winning. And each of these 2 can happen. I just fix the ordering. But how these people fight each other and how they kill each other, I do not care about that. I just care about that person number 1 will remain alive at the end. So it's possible that I kill J, or it's possible that J kills I. I do not care about it. I just care that at the end 1 will remain alive. Yes, the point is that if one of them is equal to 1, if one of I and J is equal to 1, in the case that you kill 1, the probability is 0. So the probability of that DP is 0 if you have killed 1. So one of these 2 values will be 0 already. Automatically, you do not need to care about it. You are saying DP of mask and I means I survives fights when mask fighters are in the ring. Exactly. When these people were in the ring at some point. Does that mean I's bit in mask is set? Yes. I's bit is set and J's bit is not set. So I is inside mask and J is outside, and I want to add it inside. So I go to mask plus to the power of J. Can you please explain again the initialization we did to our DP matrix before going through all transitions? Yes. So I said that initially, what is my answer initially? Let's wait a second because I'm running out of charge. I'll be back. Okay, sorry. I was running out of charge. My charge was 7%. So I'm saying that basically what I'm saying is that initially, what are the DPs that we can set? What did DP mean? DP means that, man, our current state is this. Our current state is this. These people have fought. The person who survived is person number I. This is my current state. So what is the probability that at the end person number 1 will survive if this is our current state? So the current state is DP of mask and I. These people in mask have fought and person number I has remained alive. What is the probability that person number 1 will survive at the end? So what can be our base cases? I mean, the base cases are the cases that their answer is trivial. So one base case that we can have is DP of, I mean, everyone have fought, everyone is equal to 2 to the power, its mask is 2 to the power of n minus 1. Because if you write 2 to the power of n minus 1 in base 2, it's going to be 1, 1, 1, 1, 1, 1, 1. So it is DP of everyone and 1. This will be equal to 1. DP of everyone and 1 is equal to 1. And DP of everyone and anything else like x is 0. Because it means that everyone have fought and person number 1 is not the person who has remained alive. So now, what is the probability that person number 1 will end up alive now? 0, because he's died. He's dead now. He died. So DP of everyone and 1 is 1 because he has won the game. DP of everyone and anything else is 0 because he has died. So there's no possibility that he will win. So this is our base case. And our transition will be like this. From mask, we will go to mask plus 2 to the power of j. From dp of mask and I say that let's add j to the end. Definitely, I is in mask, and I want to choose some j that is not in mask. I want to add it to my mask. So I say that when I add j, I mean j is going to be the next person in the queue. So far we had this mask, and now I'm adding j. So what is going to be my new mask? It's going to be mask plus 2 to the power of j. And I want to see that what is the probability that person number 1 will win. I know that when I add j, let's move it here. When I add j to the end, and I have to calculate the maximum over all possible choices of j. J can be anything. Over all possible choices of j, I will find the maximum of this value. I say that if j will be added, I have the bit probability p of I and j, I will kill j. So I will go to dp of mask plus 2 to the power of j and I. So my next state is that these people have fought and I has remained alive. So now what is the probability that person number I will win? That must definitely be multiplied by p of I and j, because this is also the probability that I kills j. And also there is a probability that j kills I. In that case, if j kills I, what is the probability that 1 remains alive at the end? It's going to be mask plus 2 to the power of j and j. So we have to add these two values. We have to add these two values, and this way at the end we calculate the maximum over all possible j's, and that is going to be our answer. So basically we are fixing that which j we want to add at the end. That's why we have maximum over j, because we want to have the best choice of j. We want to choose which j we want to add, but we don't want to fix who wins over whom, because anyone can win against anyone else. I mean, I don't care. At the end I want person number 1 alive. That's why in here I have plus inside, because I have p of I and j times dp of mask plus 2 to the power of j and I. In both of the cases, there is some possibility that person number 1 will remain alive. Maybe even one of them is 0, but maybe both are non-zero. For example, if you kill person number 1, definitely that dp, the corresponding dp will be 0 if you have killed person number 1. But in some cases, if person number 1 is not killed, yes, the probability will be non-zeros, and you can add them. So any of these two cases must be considered and they must be added. Is it clear? Thank you. That's wonderful to hear. I'm so happy if it's clear for you. Guys, if you have any suggestions, any criticism, I mean, in the last stream I saw some criticism that I went fast over some explanations in the last contest discussion, and I learned really from this criticism. So if there's any, feel very comfortable to say that. That's completely okay. If anything was not clear or there was any issue with the way of explanation, if I quickly went over something and you didn't understand what it is, let me know. I'll try to fix it. And I would definitely be happy if you understood it well and the explanation was good. I would definitely get happy, but I also would be, I think it's necessary to also hear criticism as well. So if there are any issues, let me know. And the last problem will remain as a challenge, LRU. It would remain in, it will remain in our Codeforces group, and you can think about it as a challenge, as a bonus problem, maybe in the next streams, either in DP stream or in Bitmask stream. Now that we know Bitmask, in DP streams we can also solve DP Bitmask problems as well. We will solve this problem in the next streams. But so far, it will remain as a challenge for you to try to accept it. Think about that. That's a very beautiful problem. Think about it, and using the things that I'm saying, you can solve them. I'm finding it hard to analyze the case where dp of mask plus 2 to the power of j and not I will not 1 will become greater than 0 with the current dp formula. Because maybe in mask plus 2 to the power of j, we do not have 1 yet. Maybe 1 has not played so far. Maybe in mask plus 2 to the power of j, 1 is not there so far. And he has not played yet. So he's not in the mask, and someone else, person number 2, has remained alive. Then person number 1 comes in and kills person number 2, and he will remain alive. Is it clear now? Man, when you are doing on lead code contest upsolve videos, you should explain bit slow. You should not go as fast as Codeforces. Upsolve it. It's my bit request. Okay, sure. Got it, I'll try to code that too. Awesome. Okay, I hope that this stream was helpful for you. Also, I put a vote on my Telegram channel to see what was the how we would rate this stream. I want to know that's how this stream was. I think that your feedback would be really beneficial. If you are not already in Telegram, it doesn't have very high probability, but just in case, I'm adding Telegram link here. If you want, if you are not there, you can check. Can you modify that song playlist question to my given a set of 8? It's possible to find path which equals all the endnotes. Yes. Or find the longest possible path. Yes. It will be my first 2400. Awesome that it's clear now. And XOR sequence, I found that answer is x and XOR y and minus x. So I don't know. I'll take a look at it next time. Yes, sure. Please ask your question in Telegram channel if it's possible. I didn't understand that which problem we're talking about, but I read it later. So ask that question in our Telegram channel, our Telegram group. Okay, guys, thank you very much. Hope to see you again in the next streams as well. And I also hope that you have learned a lot about this stream. If you liked it, I would also appreciate it if you like the video or share it, especially with others, so that more people will watch the videos. If you want to support my work, I want you to invite other people to the streams as well. I think that would be really helpful. I would appreciate it if you share the videos with others as well. Thanks a lot. See you next time. Bye-bye.